Here are the notes for day 10, just one slide, and the topic is solving exponentials. So when you have an exponential equation, which means the variable is up in an exponent, there's going to be three methods of attack. One that's pretty straightforward, one that requires a little bit of work, and one that requires a significant amount of work. So choosing the right method is important because you don't want to do the one that requires a lot of work when it can be done much faster. So the first type is called same base. If I look at the first example here, 2 raised to the 5x plus 1 equals 64. 64 can be factored down into 2 to the 6th. So I've got 2 as a base on both sides. Now all you need to do is compare the exponents. 5x plus 1 needs to be the same thing as 6. Set them equal to each other and solve. That tells us x equals 1. When x equals 1, this left side becomes 2 to the 6th, which is indeed 64. In the second case, there's no way to get the same base on both sides because 64, as we just saw, is 2 to the 6th, and 3 is the base here. So since I can't get them to the same base, the next plan is change forms. Take the exponential and turn it into log form. So the base is 3. The other two things change places, change location. So 64 becomes the argument, and 5x plus 1 goes to the other side. And now to solve for x, I subtract 1 and divide by 5. So subtract 1 from both sides, divide by 5, and you get this as your answer. This is exact. It's perfectly fine to leave it this way, but if you need a decimal, you would type this into your calculator using change of base. The third case is when you have x's as exponents on both sides. So 3 and 5 are not the same base, and I have x's on both sides, so I'm going to log both sides. If I take the log of the left side and the log of the right side, that's kind of the same as subtracting 1 from both sides or dividing both sides by 5 over here. Logging both sides is allowed. Once you do that, the two exponents drop down out front. So 2x plus 1 drops down out front, and x minus 6 drops down out front. And now we just need to solve for x, which is a little bit annoying because there's x's in 2 spots buried inside parentheses. So take and divide both sides by one of the logs, which will give you this statement, and then you can combine these into a single log by using change of base. Since they're both base 10, you can change this into log of the bottom, which is 3, log base 3 of 5. Now you've got x's in 2 spots, distribute the log into these parentheses. Okay, still got x's in 2 spots and I've highlighted them. I got to get them near each other, so I'm going to subtract this quantity from both sides. 2x minus x log base 3 of 5. I'm going to move the 1 to the other side by subtracting 1. Now I have the x's on the same side, and if I factor out an x, divide both sides by those parentheses, and you get a final answer that looks like this. That's it for solving.